Hi guys, I'm Ganesh. I head the engineering, sort of own the iPad, iPhone, mobile web clients at LinkedIn. A little bit about myself, like I came here around 10, 12 years ago. I was doing a VoIP startup, primarily building soft switches for some period of time. Then I was at Yahoo, doing a lot of stuff in their Messenger team. And then I built their iPhone, iPad apps, and Android stuff as well. And then moved to LinkedIn a couple of years ago. And I've been there since then. So, as Bill said, I think our desktop team came here and talked about a bunch of stuff, and it actually piqued a little bit of interest in you guys about learning more about how LinkedIn does mobile. So I'm here. The format is pretty open. I'm going to walk through some slides about how we decided to use Node, what's our current architecture. It's sort of an open forum. Feel free to ask questions. Anytime it sort of didn't match with what said, raise your hand.
We got a mic here, so
yeah, you can feel free to ask. I have a couple of people joining me so that you can hear the real engineering stuff. So it's not always hey, this is good and bad. So there are a few people. Arti sort of leads our server engineering efforts, and Akhilesh is one of the key engineers in our team. So feel free, and if I don't know the answers for it, I'll obviously defer the questions to them. That's pretty much it, and I'll get started, I guess. So LinkedIn Mobile, we're going to walk through what were our requirements when we started. When we came in, one of the good things that happened for us was when I joined, I had a whole management and engineering team sort of change in mobile at LinkedIn. So we are almost like a brand new team. So we were able to look at our system just from the outside and say, hey, these are the things that the system does today. What would we like it to do down the line, and then architect and find the right system for it. So we didn't have to really worry about legacy, which was a very good part about what we did. And I'm sort of going to walk you through with some slides about what and how we ended up on Node, and that's where it is. And I said typical web application, maybe it's a web application a little bit of the past or stuff like that. You generally have a model, view, controller, framework, and when we used to do a lot more server-side rendering of pages, it all used to sit on the server side. Then you had the typical Rails-based system where you had an app. It's like a Rails controller, some ERB for templating that you used to do. Then you had an active record, something like that for a database. Then we started thinking about, this mic is, some bigger systems is you really couldn't, any app which is a bigger one, if you think about LinkedIn, trying to build LinkedIn, it's very difficult to replicate the entire model for LinkedIn inside one app. It's just not possible. So you sort of have a tiered data service that you guys talk to. So it actually looks more like that, right? If you look at a LinkedIn profile page, we have a LinkedIn profile information, the person's details and stuff. We may have something like who viewed your profile, which could come from a completely different system, or you could be looking at ads that serve from somewhere else. So it doesn't turn out to be one single place where you can look information. You just have to go out and fetch this from a whole bunch of services. And then now it's in the new stuff, where some companies have now started, and I think many of them have started doing is just a little bit of starting to do client-side rendering. So you sort of pushed the controls and templating onto the client side. And it sort of would look something like this. And the next level is obviously you don't want the client to be hitting 50-odd services and getting all this data, because you lose some of the caching and other benefits which you could potentially do on the server side. So it somewhat looks like something you need for aggregation and formatting, just to understand how you can collect data from multiple data sets internally inside your system and sort of come up with something that exposes that one feature or something like that externally. So when we translated that to what we wanted, this is what it is. And we put the Node stuff in red just to say, I'll walk you through why we chose sort of Node. Is we had our iOS, we are doing iOS, Android, mobile web, iPad. We sort of layered mobile web as something which goes across the board, is because we are doing a lot of hybrid HTML5 native stuff. And that itself, I'm not going into it in a detail here, but if you guys have questions on that, feel free to ask. during the Q&A in general, but we do a lot of mixture of hybrid development. For example, our iPad app is like, I would say like 80-90% of the app is pretty much just HTML5 wrapped around. Android is predominantly native. iOS is a mixture. So we've sort of picked the right side that we felt for us in each of the platforms, and that's how it's split up. So let's walk through like what were our requirements that we actually looked at when we looked at the old stuff. This is sort of what we had earlier, which was like the browsers used to be like server rendered pages. The client was a JSON stuff that we used to do, and to build a screen on the client, it would actually entail multiple requests. So it was actually literally saying, okay, give me this data, give me the profile data, give me connection data, and then it would build the screens on the client side. And the mobile server itself was hitting a lot of backend platforms, but they were all sort of serial. They didn't have an ability to really request things in parallel. So one request per page. We wanted to get down to like when a page loaded, we just wanted one request. This is what we wanted to get towards. Client-side render, we wanted to take advantage of rendering on the client side, which with more and more native platforms, I think it's not even, meaning if you want to build something native, there's no other option, right? You can't really have server rendered pages working, so we wanted to get towards that. There's something which we have done consciously in our design, something called like a template-based API. This is from the client server perspective for us, we've moved away from resource-based to template-based, and I'll sort of talk about it a little bit later, so with some visual representation, so you guys can understand what those mean. And the reason for that is it's one request for a page, and it somehow doesn't fit in the model of a resource, because if I'm looking at a U screen or your own profile screen or a company page, it's finally translates to like multiple resource-based APIs down the line. So that was one of the reasons to do that. So we moved the HTML to JSON. Parallel server request, like obviously we wanted to like speed out stuff up. Serial is like, it gets slower, and there are a lot of components that are completely independent in a page, and you obviously want to render them or fetch the data information fast. So parallel requests. Streamlined JSON handling. So this, it sort of became like, over a period of time, I think everybody moved towards JSON. It's just faster to pass on the client. It was faster to build these things up. So people moved away from XML and stuff, other things. So we wanted to figure out a way, if it was possible, that all of our backend services anyway gave us data back in JSON, and we were going to send JSON data back to the clients anyway. So I think if it was possible to not convert this JSON data to some other thing internally, then process it and then put it back into JSON, that would be nice. So that was one of the, like, it would be good from a speed and other perspective, that if we can just take JSON, sort of massage it and get JSON out. So that was something which we looked at. Leverage blocking IO, what does that mean? Is like when you're making parallel requests or any of these things, most of your time is spent waiting. Because you're doing aggregation formatting, all you're doing is you're making a request and you wait. And depending on some kinds of requests, you can wait for short periods of time, you could wait for long periods of time. And during that time, in a general threaded system, you are wasting resources. So your threads are blocked, and it doesn't scale well. So for a specific our use case where most of the time was actually spent more on making these parallel requests, getting the data and like sort of formatting them, most of the time is spent on just waiting. And for that reason itself, it was very important that we moved to an evented system and not using like a threaded system for us. So we want an async server. The question is like, why Node? So it fit in all of our requests that we had. It is evented. It's IO bound for most of the stuff. String manipulation, obviously JavaScript stuff, it's pretty easy to do most of the stuff. As I said, I think the biggest advantage is like, because it's evented and it scales very well. Like the sockets, the number of sockets that you can open is pretty much the number of file descriptors your process can have. It's a limit that you set. So it scales pretty well. Like, while you are not doing anything with a connection, it doesn't cost you anything besides that file descriptor, which is the biggest thing that we have. And a lot of persistent connections is sort of a necessity for us. Like if you really think, look, what some requests would take a long period of time, and when the QPS increases, you have all these pending connections, which are just sitting there, you're trying to serve them up. The third piece for us was like, this is sort of, I sort of changed it to saying are doing, but earlier we used to say like, we really wanted to cut and break down silos of generally, oh, here I have a client engineer, here is a server engineer, and the client engineer would say, oh, I just want this field and I can make this UI better, and then you have to put it through some server team's queue, and it's like a half a line of change, and you're always wondering like, why the hell can't I just do it? And then you just think, it's PHP, it's Rails, maybe I know it, maybe I don't, and we just like cut it out. We say like, it's JavaScript. Most client-side guys know JavaScript, or at least want to know it, even if you hate it. So they're sort of ready to do it, and they sort of embrace it. And that is really, really what's important for us, because we really wanted a mobile team. It wasn't a mobile client team or a mobile, even an iPhone guy or an Android. So we really wanted to break it down. So with Node, we felt like, hey, that was something which was like really possible. And I just moved it to like our doing. And I think both the guys who are there in the room are sort of example. Like Aarti was hired actually as an Android engineer in our team. And then she took on to become the iPhone lead. And now she's handling our server code base. Primarily because we let people move around, and the second piece is the technologies we choose are something which all of us can use. Evented all the way down is the same thing that I talked about. It's Node is built on the concept of evented. Obviously, there are some thoughts going around, like some people want some synchronous stuff, and obviously they're pushing back. But in general, Node is heavily built on the concept of asynchronous programming. So it is evented all the way down. So if you have any questions, definitely feel free to interrupt me. So I'm going to go to the next step of like general, like these are like pretty high level patterns that we have adopted. And you would find that this is pretty common in any framework, language, anything you choose. It's not much different. It's just going to go through like a few of the Node stuff. How many of you guys here actually know what Node is, and how many of you guys have really played in it? Okay, that's good. So just going to go through like a few things that we did. We feel like, okay, these things really helped us. And you guys can ask questions anytime you feel like. Biggest thing, asynchronous stuff. Asynchronous programming generally is like, if you haven't done it, it does feel hard. But the good part is if you've done a lot of client-side programming, you have written some UI pieces, like most likely you have done it. But it's still a little bit hard, at least on the server side. Sometimes it gets too confusing. You have like dependent code where you do this, and then the callback comes back, do something else, and things like that. And it is makes it a little bit harder to imagine at first. The general tendency is to invent something yourself. And the part with that is like, you don't get the learnings of what people have already done. And so what we did in our case was, there are two primarily libraries or modules out there which does this. There is one is step, the other one is async. We sort of used both of them in different places, and both of them are good. My own personal take, and this has nothing to do with people who like async in this room, is I just felt like when I write async code, was a little bit harder for me to understand compared to step, which was pretty simple stuff to read for me. But I think both of them were really good. So I would advise to use step or async. Or if you think you've done something which you feel good, I would say contribute back to these things, because that's how we make this ecosystem better. So I would say use step or async. And there's an example, like this is like, if you're like, it's general stuff, you're opening a connection, you want to get all the users, and you say you want to find Reno. Reno's the guy who wrote these slides up, so I'm sort of presenting some of the stuff. So if he's here, you say, okay, get the stuff. So this is how it looks like for you. What step does for you is something like this. It's literally step, right? It's saying do this, do this, do this, do this. And step also lets you do some of the things in parallel with groups. And there was one minor thing that we had tweaked on it. It's like you can make a bunch of parallel requests, but sometimes only one of the requests is mandatory, but the rest of them can potentially fail. And that is something which step did not work with. We sort of patched step to handle that scenario. But this is pretty much what it is. It's like, it just makes it like really, really simple. Inside step, this is all it is doing. It's just walking through them and catching exceptions. So it's pretty easy to read the step code. This is what we have done. I obviously don't recommend like necessarily that this is like you have to use it this way, but we sort of try to be more functional programming practices in our code rather than object-oriented stuff. Primarily because of the fact, if you go back to our older slides, one of the things we said is all the node service is doing is aggregation and formatting. It's really stateless. It doesn't really, so we don't want to build a state machine of like, hey, this request came in, that happened. Like, so it's literally, it's like a request comes in, we're applying a lot of filters before and after the processing stuff, and it just sort of flows through everywhere. So we really want to get that model in. There's a request object that flows in, and it goes through function to function to function, and in a completely stateless manner. Again, this is what, I think it keeps it very simple and keeps it lightweight on our server side. It may not fit for everybody, meaning obviously if you have a stateful system and things like that, maybe it makes it a little bit harder to do it, but that's something which has worked really well for us. Yeah, sure. Yeah. Yes.
So, sorry, the question was about functional versus OO. You're talking specifically about server-side, like an aggregation layer, and not necessarily any place else.
It's a good question. So absolutely right. Just to be clear, I think most of the stuff I'm discussing is all at the server layer as of now. We do not use, meaning all of the stuff discussion is all in the server side. On the client side, that is not completely true, but we still would prefer functional if possible. Just we seem to prefer it. I think more than me, I think maybe the people in the team can explain towards it. I think they seem to like it, but you're right. Just an example of functional, like translation. You have translation functions to do, like say it's English translation, French translation, a bunch of stuff. There's another function says, hey, give me the translation function. You can give it a request object, and it's supposed to return you the translation function. And when a request comes in, we handle it. We say, okay, give me the translation function, and we actually literally pass it along in the request object everywhere. So if you have something like this, like, okay, I need to translate new connection string to something, it actually uses that and says, okay, English is going to have this. So it's just a very rudimentary, high-level stuff of how this works. Obviously, there are a lot more details around this. So there are parts of what we had in our old system which we really liked. The Rails conventions were really, really nice. It actually imposed a structure to what we did. We really felt like Node was sort of, when you get in, it's like a wild, wild west. You can do anything, everything goes. They all work, but it's harder for people to understand, explain, and things like that. So we chose to use the Rails convention in how our stuff is structured. So like our structure looked something like this. You can have it anyway. And we're also sort of using the main module, we're sort of following the Express convention, which also mirrors a little bit of what the Rails stuff is. So it sort of helped us. And we're using Capistrano for deployment. Is anybody aware of Capistrano here? A few people. We felt it's worked for us. Nothing to rave over. It does simple deploys really well. Template-based API. This is what I was talking about before. Like, what is this? So if you look at our screen, we sort of define template like this. If an image shows up, there's a text, headline, it's a summary, and some social footer. We call it like NAS updaters or internal which for like NUT1. That's our template. The next one, probably this is the old one. Like, I'm sure she's not explaining Google's social strategy anymore, but just made a while ago. I need to fix that. But so this is another template type. And when we say we break down big screens into smaller individual templates types, this does two things for us. Is from the client side, what it helps us is like the amount of time it takes to build a new screen is a direct proportional to the number of new templates that really exist there. So once you build a template, just using it on other screens is almost free. So if you have the same pattern, you're just adjusting things, it sort of is stuff. So that helps us. And from the server side, it again helps us is that like we can reuse the same way and tell the client different information. Tomorrow in the screen, like after our native clients are launched, we decide to take this first template, but instead of showing a person, put in a company and put in the company name and some details about it and have it magically show up in the stream. It'll just work without having to rev up our clients. So the clients understand a bunch of templates that it's able to handle, visual templates, I would rather put it like templates, and the server sort of determines the things that needs to get sent to it. There are examples of rollups and things like this. Again, like all this thing is pretty generic, right? I think this is just like, if the clients are built, rather than understanding and building just like people stuff, it is more like visually I've built something where I can represent any kind of a rollup of pictures, images, things, anything that you want. The next part is on our deployment stuff is like, how does it really look at the deployment layer, like the node stuff, what exactly it is. All of our stuff is behind a whip. So load balancer stuff going on. And we have Nginx as the front end for our node. Nginx is primarily there to help us to serve static content because there's a lot of static stuff that we don't want our node stuff to do. Our SSL termination, all of that happens on the load balancer. The compression terminates on Nginx, though there are node modules that do that as well. But we just have chosen to do it at the Nginx layer. And then in a given server box, there are multiple node instances. The number of node instances that we run is directly proportional, or it is one-to-one mapping to the number of CPUs cores you have it, because it's an evented system. So every process will bound to that one CPU. You don't want to run multiple of them, then it breaks down what you have done. So if you have one CPU and you actually run 5 node processes, it really means you can only do 1/5 of what it could potentially do. In the backend, this might be interesting for you guys too, because I think a lot of our LinkedIn's backend stackers, because there are a lot of PayPal people who actually moved there, and eBay folks, and sort of mirrors what has like a lot of Java services, libraries, frameworks, and stuff like that. We definitely cannot build all of them in Node, trying to do the same stuff. So what we actually did was, for everything which we could abstract out into a service or a library, we literally built one Java proxy library kind of stuff. So we would hit that proxy, and it would actually just do it on another machine. And so we can leverage all the good work that the company had already done. So it was just hitting these servers. And obviously we had to do some work on logging and tracking and stuff like that. High-level Nginx as our front end, obviously CDN for the static stuff, and we wanted to track everything. So pretty much it. It's pretty sweet and short stuff. I could go over on some of our stuff on like our mobile web frameworks and things like that, but it's more open, like whatever people have questions, areas and things, we'll discuss them.
Okay, we'll go ahead and open it up for some questions, but also those of you online, if you wouldn't mind sending your chat questions to Allison Humphrey, who's online, and she'll go ahead and feed us the questions, and I'll read those out loud. So if you guys want to raise your hand, we got a mic over to you. I see one back here.
Is it fair to think about this layer that you've introduced as sort of the view model layer, where you're building the models that would be rendered in the view?
Yeah, I think that's a good way to think about it. It is definitely like, because this APIs are screen-based, which is relevant to a view, so it is sort of view-based model. Yep.
And you have a templating engine to build those view models.
Templating engine, not really.
Okay, you mentioned templates. I wasn't sure.
So the templates, that's right. I wanted to go to like, it was like UI templates is visually to think about it. The templates that we actually send out we are using our templating system on the front end that we use is underscore. Primarily the reason we just use underscore templates is our client-side framework, which I haven't discussed, is Backbone. And so as part of Backbone needs underscore anyway. And our templates, primarily to keep our design simple, are pretty lightweight and simple. So underscore solves all our needs. So we can switch it to dust or mustache or handlebars or anything that we want. But today they are all underscore templates. And that is the template that it applies. But the server is still sending only JSON data back. It's not like really, it's not doing the templating on the server side.
Right. There's no templating you've got for building the view models. It's straight code.
Yes, because that is JSON. Like it is, again, that is the part that we didn't want to really do because there's the incoming data. All we're doing is a little bit of manipulation to make it look like stuff. That's something which we can think about, but we haven't really done.
Okay. I know there's some questions come in, and Allison's getting them. So before we go to the questions that are online, anybody here in the room have another question? Yep.
You said you are supporting mobile web, right?
Mm-hmm.
So if JavaScript is disabled, how you are solving that? If everything you are doing is client?
That is true. We will not be working very well if JavaScript is disabled. I think as of now, the more problem we actually run into it's a good question. So the first part is we still have the old server render pages for non-smartphone platforms. You can say all the old ones, so they should work. For the newer ones, iPhone and Android platforms, primarily the most of the issues that we have really seen is not that people disable JavaScript. I don't even know whether there's a setting that shows up. Anyway, the more issue we run into is that on and off, people turn on private browsing and the cookies disappear. That is the problem that we hit more often. And we sort of message the user and potentially we can do something with local storage and stuff to work around it. To answer your questions, like in this format, like with JavaScript stuff, we don't solve it today, but that is not a framework stuff because we're using underscore templates, you literally can take the templates and do it on your server side. So you can literally do the templating on the server side. If that is as a feature, product feature, we would want to support. Oh, sorry.
The question is on the backend side, you showed Java Proxy, that kind of RESTful layer that kind of converts into your backend services into a JSON responses.
Actually, the Java Proxy, yes. So this is Java Proxy are for services that do not expose RESTful interfaces. If they were exposed RESTful interfaces, we will just directly hit them. These are for like libraries, which we want to turn into services. For example, like a good example would like to do like Elix, right?
Yeah.
You want to talk about it?
Yeah, I can talk about it. So Java Proxy is something that hits services like, for example, so we have a service which basically tells us whether you want to enable a feature for a particular user or not, which is like an A/B test feature.
A/B test ramping library.
Something like that. Since it's a LinkedIn service, it's a Java service, and they do not expose any RESTful interface that the Node service can directly hit. So the Java Proxy sits in the middle, talks to this Lix service, gets the response back from Lix, and then Node can hit it directly as an HTTP request and get back the response. And therefore, Node doesn't have to directly talk to Java. It can talk to this Java Proxy, which talks to the Java.
So, to add to what he said, I think what we realized is slowly, like we're doing some, there's a lot of work that has been done at LinkedIn, right? As you would find available, there's a lot of smaller libraries and things that just exist and that's available for free across the company. When you switch to a new platform like this, one of the first things is, hey, I need to rewrite all these things. And just wanted to bring it up that you don't necessarily need to rewrite all of them. There will have to be some amount of work, maybe converting your libraries into individual services where it makes sense. It may not make sense. Like if in a request you have to do something like thousands of times, like obviously that model will not work. But if it is purely, you can abstract it out into like, okay, as you said, like find out for a user some details or things like that, we can leverage it using a proxy that sits up there.
For the server-side Node.js, how mature are the tools, especially IDEs and debugging capabilities as well?
So I'll add something and then these guys can say if that is true or not.
Sure.
There weren't a lot of IDEs before. I would say a few months before when we were trying, I think last year we didn't see a lot of good IDEs, but I think it's a very tough question to ask people doing JavaScript development as to which editor you like. Let's try this in this room, like which editor do you guys like? And I think the answer is going to be like, I think all these people multiplied by 2 or something like that. Somehow I find that JavaScript people don't like one editor. That sort of mirrors into the IDE stuff as well. But what we did find is we've been using IntelliJ now for a while. IntelliJ has a very nice node plugin. It lets you debug, and it works really well. And then the second part is the node inspector is there, and It literally lets you connect using Chrome and debug, break, look at heap profiles and everything. So that hasn't actually hurt us in terms of not having that. Even when we were not using IntelliJ before, with the node inspector, it was like we were able to do stuff. But there is a little bit of productivity loss because of not having that.
And to add to that, Node even provides remote debugging capabilities. So even if you're like running your server in a beta environment or a staging environment, you can actually like connect to it remotely and debug through the same Chrome inspector that you use for your local machine. So it's I don't see any issues currently with.
Definitely IntelliJ has helped a lot of the client developers who've predominantly been used to IDEs. They want export as an IDE, Eclipse as an IDE. So they love to put a breakpoint, step, and debug. With Node Inspector, it's a little hard because you just need to get used to it. With IntelliJ, you can actually debug evented requests, and you actually can trace the callbacks and see what's going on. So IntelliJ actually has helped a lot.
There's a few questions that came through online, so let me go ahead and read some of those. I'll read two, and I'll let you go and respond to it. One says, if you had to start all over again, would you do anything differently? And the second question is, can you brief us a little on the pros and cons of using Node.js?
If I had to start all over again, I think I would stick with this, at least for now. But our general philosophy is if you're doing a newer project, we want to look at everything from the scratch. So the answer to the question is like right now, Node, yes. 6 months down the line, a year down the line for the newer project, I don't know. I think in general, the shelf life of products, if you really look at it, it's going down, right? I mean, the market moves so fast. Like trying to say that, hey, you're married with Node forever is not what it is. I think you need to build your system such that in our model, like the clients are built with their own MVC framework and stuff. Even if you change the Node back into something else tomorrow, they will work well. But that doesn't mean you keep changing it. As of today, we'll stick with Node. And I'll sort of come to the pros and cons part of it, which would sort of give a more explanation to it. And I think these guys should give their views as well. As the pros is exactly all the stuff we said. Like we needed something evented and something which is really fast. Node is like, we were like really surprised with how fast it was compared with like, obviously we looked at Rails and other stuff and it was really, really fast. The second is, meaning at the end of the day, as we evolve, like how many people actually would ever write code in assembly, right? You want to have more frameworks and stuff available. So you moved on to C, then C++, Java. As things evolve, you want a better programming language from your perspective. And something for us which was important was sort of a REPL, like where you can just write things and learn. And JavaScript is so easy and natural for us to learn. So that was a big pro for us. And the other big thing which I sort of emphasized heavily is like we wanted to build a mobile team, not client, not server, not any of this thing. That was like really, really important for us. And I think like Node has just helped us completely eliminate that gap. Like we actually do not have a single engineer in our team who has not built something on the server side. And when they get features completely down the stack. They build the UI, they write the server code, they might write even a little bit of the Java code on the back end, but they do it end to end. So overall, from a productivity, from an engineer's perspective, and the fact that they are learning new technologies has been really good. What are the cons? The cons are like, for us, anytime you are the first set of people that try something, when you run into problems, there aren't a lot of people that can help you. Like I think we are pretty much the largest Node. Maybe Yahoo stuff may say they are, but I think I believe like strongly that we are like one of the largest real production deployment for Node out there. So when we hit problems, it's a funny thing. Like I had a new engineer in my team, and we were trying to profile some performance stuff and things like that. And for our Java stuff, we have an entire Java performance team. So you just do your stuff and you say, Java performance team engineers will come and tell you blah, 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 to tune your GC. And she was saying, hey, do you have a Node performance team? I said, yes. And I said, it's you. So that is sort of a con. But as an engineer, it's a pro because you actually get to learn. Like you don't want everybody to solve everything for you. I think it's have it a little bit challenging. Just to add to that, though, we have not run. We are really running that system on Node for now a year and a half. We have had our moments of outages and things like that, but I think it has been far and few. So we really love doing it.
Almost everything. But if there's any specific question that you're looking for.
Yeah. So you mentioned the mobile native app and the mobile site. They kind of use the same JSON from backend.
Mhm.
So I'm interested in the native apps. Do you use the same compile dust templates, and do you cache them using local storage and stuff like that?
Okay, so first thing is like on the mobile side, we are not using Dust. We are just using underscore templates. And the second piece is we do literally share the same web view. It's literally, for some of the stuff like profile would be a good screen. Like the profile screen on the web, the same JavaScript runs inside the native app, and it caches exactly the same way. So all your templates are cached in local storage, everything else exactly the same way.
Okay.
But it doesn't mean we do the same thing on Android, because Android, we have generally seen that the web view performance is not there yet. So that is still a native stuff. But wherever we use, yes, if the web view is there, it's cached exactly the same way.
And it is still even in Android, it is still the same JSON contract, right?
The JSON contract is exactly the same. The templates and all those things are exactly the same.
So just like you would have an HTML template, you would have a native template in this, and it accepts the same data, renders the same.
Thank you.
Question back here.
So for anyone wanting to move to production with Node.js, do you have any suggestions, or do you, in your experience, do you have something that we should be kind of watching out for?
So I think it's a general, like it is no different than if you wanted to go with Rails, PHP, or anything like that. Right? The fundamental thing is before you build your feature or stuff is you need a framework. So the framework is what basically like you can pick up Express or Connect or something like that. You need a good framework. Framework means just the layout, the architecture that you choose. Then the second thing comes is you need a logging system. You need, like for all the things like PayPal and bigger companies, like it cannot be like something we think about later, because at the end of the day, meaning after you put the service out, how do you really see what it is? So you need some of your infrastructure stuff in place, like have the logging going, have your metric stuff going, and build the framework out. I think that is the first piece for you to make sure that you don't roll out when you really want to get it out into the production stuff. But for the rest of the stuff, in all honesty, it's not trying to give some spiels on like, hey, Node is great or anything like that. For our particular use case, typically for doing aggregation and formatting, and I want to clearly say, because Evented has its own pain points. If you do something more CPU intensive on every single request, like if you're going to do a heavy computation, Evented is not the way to go, because you're going to block, and all your latency for every single request that is after that is going to be slower. So it is like, there is meaning this is not a solve all for everything. So you need to choose the right thing. But if Node is right for you, I don't think you would run into any problems getting into production. Obviously, you need a lot of help from your SRE team, so you should work with them so they understand what Node is, how it is deployed and things like that. How do you upgrade Node and build into the operational piece of it, like how you would want to run Node, set up your script so that it runs on, like bounded to every instance, give it the right memory and stuff like that. But that's no different than taking a Rails app to production. You can do a prototype at home, but if you want to take it in prod for a big company like PayPal, I think it has its set of challenges, but nothing unique to Node.
So as a follow-on to that, backing up to when you guys first decided to use Node, what was kind of did you go through a pilot project? How long did that take?
Yes, so that's a good question. So what we did was, when we actually said, okay, these are our requirements, we used to be a Rails app before. So we actually evaluated between Rails and Node. So we put up a prototype, we actually tested it. The prototype obviously didn't have all these things. We put up a prototype which had a basic feature, very simple feature set, and we did a heavy load testing on it, purely performance, to say, okay, does this handle it? And in that one, I think Node just blew away us. It was just like 10x faster. It was just 10x faster. Now, maybe we didn't, like we've been doing Rails, like a lot of the people in the Node team were actually heavy Rails fans. Like so they were pleasantly surprised with the numbers as well. So we did a lot of legwork to do that. And we also analyzed the cons for us at that point of time, right? At that point of time, the cons for going to Node was extremely high, right? We are in the same boat as you guys, because you guys don't know, like you can hear me talk about it, but unless you guys try it out, you won't know. And when you put up your cons, the biggest thing would be like, hey, this is Node, like nobody knows about it. How well is it going? Yeah, somebody from LinkedIn gave a talk, but do you want to bet your next projects on it, right? So that was one of the stuff for us. And I think the easier part for us was that, as I said, like we had a whole team overhaul at LinkedIn, so a lot of people came in new. So we had a charter to change it, and there was less legacy stuff in mobile because like mobile was like 3-4% of site traffic last year, so we're now 25%. So I think we had it very easy to do it. So you may face some of those challenges. Anytime you change, it is harder. But besides that, I think that's what we did. We ran a test. We looked at the pros and cons, and one of the biggest cons was, hey, this is unknown stuff. Besides that, everything else was good.
Okay, a few more questions that came online. Do you have a node service operation per UI template component exposed, which then communicates with your platform services?
You say that one node service per UI template?
It says, do you have a node service operation per UI template component exposed, which then communicates with your platform services?
I would say no. Each node instance is the same. Like they're all replicated. And each node instance has the responsibility of fetching data from multiple backend services, aggregate them, format them into various templates, and based on the request, so if it's a profile request, it would send back a JSON blob with multiple templates for that profile. And if it's some other request, it would gather up the templates for that request and send it back. So there's no concept of one node instance per template.
So I would change, like I would put like there is like, for given in an app, the app in our mind is a phone, like whether it's Android, iPhone, mobile web, or anything which follows the phone form factor, and from a UI design perspective, it is one thing, is an app for us. So for given a phone app, we have a node server that can handle all your requests for it. So when you say tablet, the designs are completely different, and this is where you will see the template stuff, because the templates are now radically different, because you don't want to take your phone design and just blow it up on iPad. That's not what you do, meaning you want to build a new UX, user face first. So that itself is its own server, tablet server, which handles a different set of APIs and routes and things like that. So the delineation is more at an app level. If I understood his question correctly, it is not at like a URL or a route or a template level.
But then the common part is that both the mobile server and the tablet server, they have some common libraries to request data from the backend, because they are doing almost the same thing when they're requesting data from the backend, but the formatting and the templating is different.
Like the networking piece, on the shared infrastructure, like logging and metrics, all those things, like obviously you don't want to write them again and again. We just built common libraries for them that we can just leverage on all these apps that we build.
Okay, another question came through. How scalable is Node, and do you see any performance issues?
So we went down from 20 Rails servers to, I think, 2 when we deployed last year. The total mobile servers today that we run on are 5. We have 5 servers, tablet runs on 2 servers. So it scales like crazy. Obviously, I think part of it is also overshadowed because the machines also get faster every year. So some of the numbers might be skewed, but it does really, really well. For a typical use case, what I think the typical use case is we spend a lot of time waiting and getting data from a lot of backends and aggregating. Now, if you change that and say, okay, I need to start doing some more computational stuff, maybe these numbers will just be wrong. We actually, so again, funny stuff is that our SREs and operation teams will not provide less than 3 machines. So if we say we need 1, they say no, we'll give you 3. So yeah, so we need 3. That many. Yeah, good
Can you guys talk about some of the tools and processes that you use to ensure the quality of your JavaScript?
Actually, okay.
So we definitely have JSLint and JSHint, both run, and it's a part of our pre-push. So your code will not even check in. It'll fail if it fails any of these tests. We also have unit tests, which are written using Mocha framework. Every feature requires it. So every time you want to check in, we run a small set of sanity, so we don't want to delay the commit process. And then when the commit code actually goes into, we have a box, like a staging box, where it runs a full integration test, full regression test, and if the tests fail, then it is not approved to go to production. So we have that. We also have integration tests where we actually test the end-to-end route. So we actually stub out what the expected JSON is, make the request, and you actually expect that response to come back. So this is what we have for the server side to make sure that we actually don't.
So yeah, I'll add a few more things to it. We've done a lot of work to answer your question to create our fixture mock stuff. What we really do is we use this concept of like a VCR or recorder facility. It's like you hit the live data and test it, but you can capture that data from the input and output and record them. So you know, okay, when the input is this, the real data gets back this. So that once that is fixed, and we've done something, I think one of the stuff we should do is to sort of open source. We use something called like, there's a tool which lets you intercept the proxy, like the TCP connections on a process. We run a proxy to capture all this data, and we sort of replay it and test it. So that means that all of the routes, and it's much easier on the server side, it's like you have a fixed set of APIs routes that you support, so we just go through all of them literally in one set. And to add to what you just said, I think we have actually reached a point, at least on the server side, we feel fairly comfortable with that all these tests run that we're good is we have started doing continuous deployment for some of our projects. It's not ramped up completely, which means like if you check in our code, as you said, the pre-push happens, the server integration runs, we push the code out to an beta box where testing happens, we push it to staging, which is our next pre-prod, which again test happens, then we push it to canary, where we look at our graphs afterwards, and then it gets deployed. All of this is automated, like there is nobody involved in it, it sends emails and stuff. So you check in code, it goes out. And we're working through, like it is live in a controlled manner. We turn it on and we see that it goes through. We have not just turned it on at all, but that's sort of our goal. Our motto is to like make sure that from a development process, we are doing continuous development on a trunk model. So anytime anybody checks anything into trunk, if it passes all the tests, it will ship out. And we release like once a day today without that as well.
Just to add to that, like as a first level, even like basic integration tests, which just hit all the routes on your server and you get a 200 OK back, even that we have seen covers so many basic cases that you normally mess up. So like just like hitting all the routes, getting a 200 back is more than sufficient to like get basic test coverage going before you go into recording the fixtures and stuff like that. That also is a very, very good tool to start with.
The most satisfying part is the code actually goes live. You check in code, it's out live within the day. And people love it. Like all the interns, they just love the fact that their code ships out within a day. They don't have to wait for like a month for the code to ship out.
Question. First of all, thanks for coming by and sharing your experiences. It's always good to hear first-hand experiences, especially from engineers' mouths. And the question I have is, like, if you're willing to share, like, how big was the code base when you decided to migrate from one platform to another? And sort of, if you can talk a little bit about what strategy you follow to make sure that from functionality-wise you're covering, as well as other strategies on, like how often do you, like, in the past, you've been able to change your platform? And like, what keeps you stable and still be fast to push out live?
So when we started off, I think the good part was we didn't actually have to look at the old stuff at all because that system definitely its life had ended, and we actually did a complete design overhaul. So it was not just that we moved the server; we actually created a complete set of apps. So if you go back in time last year, during this time, or like we launched a completely new set of apps across the board, where we radically relooked at our design, like UI design completely. So we never did that analysis of how much we have before to here because we just rewrote the whole piece. So that was one thing which was not heavily into our consideration. And I do believe like just converting, at least you need to convert full apps, like trying to slice and dice that, okay, these few things let Node do it and things might be a little harder in my own personal opinion. So I'm not sure about that. The second part of the question, I sort of didn't get it. Do you want to like replace like? Yeah, I think yeah.
How you narrowed down into like basic features? There were so many features in the previous app.
Oh yeah, it was all design driven. So it was nothing to do with engineering to say, okay, I'm going to just cut this. Like nobody's going to like it, right? I just say, hey, I have Node. I'm going to move to Node. I'm going to cut away 20% of your features. So I think it was primarily product driven and a UI driven, and where we felt like from a design perspective, we just needed to change it completely. So that drove us more than us making like a call, like we'll do these things.
So I suspect you have proprietary internal Node modules and libraries that you use. Do you guys use internal private NPM repo? Do you use Git? How do you distribute modules internally?
We are just planning to do that. We haven't done that yet. We have our internal node modules, and right now they exist as Git modules. They're basically Git repositories, but we really want to move to an internal NPM server so that it becomes much easier to.
From a deployment perspective, it makes it easier. So the main reason we ran into the problem with the Git works very well for everything, but we also have some. So one of the things that Node does really well is if you have C, C++ based code, Node plugins work really well. You don't need to do anything. You just literally take it, put it into one of their, Node has some documented steps how to create plugins. It works really well. But then it's now you're going to have compiled objects. Now you don't want to do it on a dev box. It has to be on a proper build machine and things like that. And that's where an NPM would really help us. Like somebody really builds it and actually checks it in. So sort of there. But as you said, like,
right now it's true that we actually have to check in all our submodules when we upload it to Git. And when we deploy, we actually deploy the whole thing with the submodules.
But the good part on that for Node itself, I think the nice part is Node itself is one big executable. So you build it once, you check it in. So you don't need to really worry about Node's dependencies finding, because generally in all these programs, right, you get into this crazy like library and dependency hell of so many things. So that's one problem. Now, Node does have an issue, a little bit of a trickiness where if you use a submodule, like if you use a plugin and one of your
submodules,
like the other plugins also use that plugin, you need to work with it to find a good hierarchy, like architecture in place. But it's not very hard to solve.
Great, guys. Help me give a warm welcome and thank you to the folks from LinkedIn. Thanks for coming out.
Thank you.